All right, so now that we've handled amplitude changes, it turns out that we can change the period. Right now, our period for both functions is 2 pi. And what I mean by that is over one full rotation, one complete circle, right, the cosine graph or the sine graph, right, are going to basically do everything that they're going to do, right, from 0 to 2 pi. And then it's just going to keep repeating that pattern every 2 pi, every 2 pi, over 2 pi. Again, hopefully that just makes sense because of the coterminal angles we talked about way back when. And what we found, right, to change the amplitude, to make these waves bigger or smaller, we multiplied something to f of x. So if I want to change the period, which means I'm basically taking this and horizontally stretching it or horizontally compressing it, right, that means I'm going to be impacting the period, which we also call frequency, and we'll get into that as well later in this chapter. And so if multiplying something, a constant, to the output caused something vertically to stretch and compress, then it would only make sense that to get something to stretch horizontally or to compress horizontally, we better be multiplying something to the x. And that's exactly the case. But it's kind of strange because look what's going to happen. So let's go ahead and for a normal sine function, right, it does everything it's going to do between 0 and 2 pi, its period. So if I want to look at sine of bx, that means that this bx has to be, fall within that data set. So if we do this and write it in terms of a inequality, I'm basically saying that this bx, I'm sorry, not 2x, this bx has to occur within this normal 0 to 2 pi cycle. However, if we solve for x, if I divide everybody by b, right, what we end up getting, 0 divided by b is 0, and we end up getting that x is basically 2 pi over b. So we went from a period, right, of 2 pi, right, and now my interval is 2 pi over b, and so we have basically a period of 2 pi over b, whatever that b ends up being. So what ends up happening here is that we're actually performing, I guess you could say, a division, right, of our, so even though we're multiplying, we perform a division, right, to all our x values. Notice that happened to all the x values. And that's important because remember what our big three were, right? For sine, we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I have something like sine bx, we're going to take all these values and we're going to divide them all by b, because that's basically what's happening throughout, all right, the period. All values of x get divided by b, the endpoints and everything in between. So my endpoints and my everything in between are going to get divided by b, which basically impacts the period. It can either stretch it or shrink it. And with that knowledge, here's what happens. If b is greater than 1, what we actually have is a compression horizontally. All right, and let me just go ahead and do an example. So if we had sine of, let's say, 5x, all right, then that means, right, that what used to be a period from 0 to 2 pi, right, our new period, that's kind of what we have there, is going to be 2 pi over 5. So this guy, right, is going to do everything that it's going to do over 0 to 2 pi over 5. And if we compared that, right, here's 0 and 2 pi, and 2 pi over 5, I'd be breaking this up into fifths. And so that would be right here. So here's 0 to 2 pi over 5 compared to a 2 pi interval. And so you notice what happened. What used to happen over a complete interval is going to happen just over that thing. So we're taking the sine graph and we're compressing it. So with b's greater than 1, there's actually a horizontal compression. If b's a fraction between 0 and 1, right, then what we're going to do is get a horizontal stretch. All right, and again, let's just look at an example. So if we have sine of 1/5 x, right? This means that I'm going to be taking my new period, right? It's 2 pi over b, so we're going to have 2 pi over 1/5, which turns into 2 pi times 5 over 1, which turns into 10 pi. So my normal period is from 0 to 2 pi, but by multiplying it by 1/5, my new period is from 0 to 10 pi, which is huge, right? So we're going from something at 2 pi, and then we have 4 pi, and then we have 6 pi, and then we have 8 pi, and we have 10 pi. So sine, right, does in a normal cycle does that, but in this cycle, where's the halfway point? 5 pi. So this over this one, it's basically going to be doing that. So we've taken this sine graph and we stretched it out. So that's something that's a little different from our amplitude, right? When a was positive, was greater than 1, we stretched. When a was a fraction, right, we compressed. But because we're dividing all our x by b in that work that we did, we're actually doing things in reverse. So if b is greater than 1, there's actually a compression going on. Our period is getting shorter. If b is between 0 and 1, then we're actually getting a vertical stretch. We're basically taking the action and it's getting larger. Oops, I think I lost you guys there. I'm sorry. So again, here's a 0. There's a 2 pi length, and then here's 10 pi length. So we're basically taking the sine graph and everything that I did on that first 0 to 2 pi. Now, right, it takes a 10 pi interval to make sine do everything it's going to do. We've essentially stretched the graph out. All right, and again, what we're doing with all our x values, just like we did with the new period, to get the new period, I'm taking my old period and dividing it by b. And that means all the x's have to be divided by b. So that's how we're going to be manipulating all our data points if we have a b in there. So let's go see that in action.